For these, this is the main bulk of what we're concerned with here in these last three sections was solving. The other things were just kind of the applications of solving that we might throw in there. But these I want to solve. And remember, I've got three methods: factoring, completing the square, and the quadratic formula. Okay? I always want to check factoring first. So with this first one, I'm going to subtract the 6 from each side. I want to get everything on the same side so I can check to see if I'm able to factor. I get 3x squared minus 6x equals 0. And then if I want to solve this one by factoring, I've got two options here. I can factor it the way it is. I can factor a 3x out, which leaves me with an x minus 2. And I was solving by factoring. I said each factor equal to 0. So I do the 3x equals 0, and I do the x minus 2 equals 0, and I solve each. Here I divide each side by 3, so I find out that x equals 0. Here I add the 2 to each side, so I find out that x equals 2. And so those are my two solutions, x equals 0 and x equals 2. And that's it. All right. For this one, you could have divided everything by 3 first and then factored it. You'll get the same two answers. For the next one, again, I always want to start off to see if factoring will work. I'll build a bridge. That's a negative 8, two numbers that multiply to a negative 8 but add to a positive 6. Well, that doesn't look like it's going to happen. So I can't factor because I can't come up with those two numbers. So this one, I either want to do completing the square of the quadratic formula. When I look at this, I see an a value of 1 and a b value that's even, which means completing the square is the easiest way to go. So I add the 8 to each side. And you may do a quadratic formula for this one. That is fine. But I'm going to do completing the square. I get a blank there, so I have x squared plus 6x plus something equals 8. I complete the square, b divided by 2, and square it. Again, take that off to the side if you need to. Divided by 2 and square it. That's a 3 squared, which is 9. So I'm going to add 9 right here. Whatever I do to one side, I have to do to the other side. Make sure you add the same thing to each side of the equation. And over here, this factors into an x plus 3 squared. This equals a 17. And now I can take the square root of each side. So I take the square root of each side. That gives me an x plus 3 equals plus or minus the square root of 17. And now I subtract the 3 from each side. And I'm going to leave my answer in this radical form. I'll have x equals, say, negative 3 plus or minus the square root of 17. And that's it. And once again, you may use your quadratic formula for that one. If you use your quadratic formula for that one, you're just going to have to simplify a bit. Okay? For number 14, there's two options here. Since it's written as x squared minus 64 equals 0, I'm going to solve this one by factoring. This is a difference of squares, so it factors into x plus 8 and x minus 8. And now factoring, I said each factor equal to 0. So I do x plus 8 equals 0. I do x minus 8 equals 0. And I solve each. Here I subtract the 8 from each side. Here I'm going to add the 8 to each side. So I find out that x equals a negative 8. And x equals a positive 8. And those are my two answers. And if I want to abbreviate that, I can write it as x equals plus or minus 8 would be the other option, okay, for expressing my answer. All right. And that leads me to the other option for solving this, which I'm going to use in number 15. Number 15, I've got x squared equals 4. I can just take the square root of each side. And number 14, I could have added the 64 and then taken the square root. The only difference is, when I take the square root, I just have to make sure I remember when I take the square root of each side, it's got to be plus or minus that value. So this is plus or minus the 2. All right? And this one could have also been done by factoring. Had I subtracted the 4 from each side, x squared minus 4 equals 0. Now, once again, I have a difference of squares. So I do the x plus 2 and the x minus 2. And then set each of them equal to 0, I'll get two answers. So make sure that if you use the square root, you remember to do plus or minus. Number 16, the way it's set up, I'm going to start by building a bridge. I'm going to check to see if I can factor this. So I build a bridge. That's a positive 18. Two numbers that multiply to a positive 18 but add to a negative 7. I can't think of any, so that's not going to happen, which means I just can't factor it. So I either go to completing the square or my quadratic formula. In terms of completing the square, I'm looking for an a value 1 and a b value that's even. Well, I don't have an a value that's 1, and I don't have a b value that's even. So this one, I want to use my quadratic formula. Okay? So remember the quadratic formula. Let me put it up here. A lot of markers in my hand right now. But the quadratic formula is this guy. opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And make sure you have that committed to memory, especially for the upcoming quiz. All right? So for this one, I'm going to do opposite of b, so that's a 7 plus or minus the square root of b squared minus 4 times a, which is 3, times c, which is 6, all over 2 times a, which is the 3. And now it's just a matter of simplifying. 7 plus or minus the square root, that's going to be a 49. What do we got here? A 24 times 3. Is well, it's going to be a negative or a minus 72, it looks like. And then when I subtract what's in there, I'm going to end up, over 6 equals 7 plus or minus the square root. That's going to be a negative 23 over 6. Now I have to simplify that radical. Keep in mind that when I have a radical like this, I can split this up into 7 plus or minus the square root of, this is a negative 1 times 23. I still know how to take the square root of negative 1. The square root of negative 1 is an I. So that's 7 plus or minus I root 23 all over 6. Okay, so what I end up with is two complex solutions here. For number 17, the first thing that I might do is subtract the 4 from each side. And that's going to give me an x squared plus 6x minus 4 equals 0. And I do that just to see if I can factor. I build a bridge, two numbers that multiply to a negative 4 but add to a positive 6. And it's not going to happen. All right. So really, I subtracted that 4 for no reason. I want to bring that 4 back over and write it like this, because this is one where I have an a value that's 1 and a b value that's even. I'm going to solve it by completing the square. So I take that b value, the 6, divided by 2, and square it. So that's 3 squared, which is 9. So I'm going to add 9. Whatever I do to one side, I have to do to the other side. So I add 9 to each side. Over here, this factors into an x plus 3 squared. This is a 13. I take the square root of each side. So I get x plus 3 equals plus or minus the square root of 13. And now I can subtract the 3. And I'm going to leave this in radical form. Once again, I've got x equals a negative 3 plus or minus the square root of 13. And that's it. Number 18, once again, I start off by building a bridge. Two numbers that multiply to a 12 but add to a 6. That's a 4 and a 2. So since I can come up with those two numbers, it means this one can be factored. There's a 1 out front. I get to use my shortcut. So it's x plus 4 times an x plus 2. And now I just set each factor equal to 0. And look at how much easier this is than any of my other methods. I subtract a 4 from each side, and I find out that x equals a negative 4. Here I subtract a 2 from each side, and I find out that x equals a negative 2. So I get two answers, both of them very easy to find. Okay? In number 19, the first thing that I notice about number 19 is all of these have a 2 in common. So the first thing I would do is divide everything by 2, just to make this thing look a little bit simpler. That's an x squared plus 2x minus 4 equals 0. And then I might see if this thing can factor. I build a bridge, two numbers that multiply to a negative 4 but add to a positive 2. Not going to happen. So this one, I've got an a value that's 1, a b value that's even. I'm going to complete the square. So I'm going to add the 4 to each side. So I get x squared plus 2x with a little space equals 4. I do b divided by 2 and square it. So I take the 2 divided by 2 and square it. That's a 1 squared, which is 1. So I'm going to add 1 to this side. Whatever I do to one side, I have to do to the other side. So I end up with an x plus 1 squared equals 5. And now I take the square root of each side. When I do that, I have to remember that this is going to be plus or minus the square root of 5. And now I subtract the 1. And I leave my answer in this radical format. Negative 1 plus or minus the square root of 5. Okay? And number 20. Once again, the first thing I'm going to do when I see this, I see a negative out front. And that's bothersome. So I'm going to divide each side by this negative, which is going to give me an x squared plus 4x minus 3 equals 0. And I'm going to see if this thing can be factored. I build a bridge. Two numbers that multiply to a negative 3 but add to a positive 4. I can't think of any which means this thing can't be factored. So once again, I'm going to go to something like completing the square or the quadratic formula. I'm going to complete the square. I've got the a value of 1, the b value that's even. I add the 3 to each side. X squared plus 4x with a little space equals 3. I do b divided by 2 and square it. So 4 divided by 2 and square it. That's 2 squared, which is 4. So I add 4 to each side. So I find out that x plus 2 squared equals 7. I take the square root of each side. So I find out that x plus 2 equals plus or minus the square root of 7. And then I subtract the 2. And when I do that, I come up with this answer, x equals the negative 2 plus or minus the square root of 7. And that's it. Number 21. Once again, the first thing I always want to do is check to see if it can be factored. I build a bridge, two numbers that multiply to a negative 6, but add to a positive 1. That's a 3 and a negative 2. So this one can be factored, but I can't use my shortcut. I have to split up the middle term. Remember, this is the one where I'm going to do factoring by grouping and say 3x squared plus 3x minus 2x minus 2 equals 0. I split up that middle term, that x, into a 3x and a minus 2x. Now I factor by grouping. Out of the first group, I can factor out a 3x, which leaves me with an x plus 1. Out of the second group, I can factor out a negative 2, which leaves me with an x plus 1. So now my two factors, if I see these binomials that we have in common, that's one of my factors is the x plus 1. If I were to factor that out, it leaves me with a 3x minus 2. So these are my two factors. Solve my factoring, I set each factor equal to 0. And I solve each. Here I subtract the 1 from each side, so I find out that x equals a negative 1. Here I add the 2 to each side, so I find out that 3x equals a 2. And then I divide each side by the 3, so I find out that x equals a 2/3. And then, of course, my other answer was x equals a negative 1. So my two solutions here are the negative 1 and the 2/3. And that's it. Hope this was helpful, and good luck.